All right, welcome back. Let us finish up finally this set of slides on arrays and vectors. The last thing we were talking about is reversing an array or a vector. And we noticed that we can get this working by swapping. Swap the outer edges and then work our way inwards. And we figured out that like we have to swap these guys, 0 in size -1, then 1 in size -2, and it's always size over 2 swaps in total. All right. And you're going to use integer division to calculate the size over 2 so that we don't like accidentally try to swap something in the middle with itself. So that's perfect. So no rounding, integer division. So let's spell all that out and go from there. Okay. So yeah, we're going to need a few things. We're going to let me draw some stuff. Let's pretend we have these things. So like here's the vector that I would like to reverse. Let's say I've got 7 things in it, just for fun. There, and here, let's put some stuff in there. Doesn't have to be in order though. So those are the valid indices, and so our job now, right, is to swap this guy and this guy, these two, and then finally these two, and we just skip this one in the middle. We don't need to do anything for that one. So it's going to be size over 2 swaps, which is 7 over 2, integer division, that's 3 swaps total, okay? And so we need to, the very first thing, right, is swap index 0 with size -1, and then 1 with size -2. We're going to have to iterate through this array, right? Or vector, half of it. We're going to have to iterate through half of it essentially. And so I'm going to need like an iteration variable. Like what, let's save the left side, right? Because we can always calculate the right side using this. Let's save the left side of the thing I'm trying to swap right now, right? Because then we can use this also to calculate the right side. So yeah, we're going to iterate size over 2 times, starting at index 0. Like that's the first candidate for swapping with the end, right? And then we'll increment I++, and then like we'll swap this one with 1 away from the end on the other side. Like that's the goal there. So iterating that many times, and notice how using your left index you can calculate the right index, the one that you want to swap with. All right, so it's always going to be I and size -1 minus I. Do you see it? So like this one is 0, and then if the size is 7, size -1 minus 0. That's 6. That's perfect. That's my first index to swap with, and that's what I want to keep doing. So I'll do the swapping, right? I'll need my my special temp variable. Do that, and then do that. That will do the swapping properly. So I just do that for every index that I want to swap, and it's size over 2 times, right? As long as I is less than size over 2 times. So that's 7 over 2 integer division. So we're going all the way up to index 2. All right, so 3 swaps total. And then we do I++, and notice how like this calculation still works. Like I want to swap index 1 with index 5, and notice that I can get the 5 from this. 7 minus 1 minus I, which is also 1. That's 7 minus 2, so 5. Perfect. That is the correct index that I'll swap. And then I++ one more time, right, to get index 2, and I want to swap it with index 4, right? And that works again. It's 7 minus 1 minus 2 now, which is in fact 4. That's beautiful. That will give me the other side that I want to swap with always. Okay? And so that's going to be the iteration. I want to iterate exactly that many times, so I is less, because it starts at 0. I is strictly less than size over 2, and that's perfect. All right, so that's going to do it. Let's code it up now. Oops. I did that backwards. There we go. So let's make, let's include vector, because we can reverse a vector. But the same code is going to work for an array as well. You'll just have to hard code the size of the thing. So there's my vector, and I would like to do my for loop now. So for start I at 0, right? Go all the way till it's less than size over 2 times, I++. And it's not size over 2, right? It's v dot size over 2, really. In this case, I++. And then notice how this loop is going to iterate exactly size over 2 times. That's perfect, because it goes up to, right, size over 2 minus 1, and it starts at 0. So that's size over 2 times total. And I'm getting the indices correct for the left side always. Okay? So now it's always inside of this loop, I want to swap indices I and size minus 1 minus I. Right? Because like you start your way at the end, that's size minus 1, and then minus I each time because you're working your way inwards, right? Moving your way to the left there. And so remember how to swap. Got your fancy slide right. Not this one, is it? Where did it go? This one, the rainbow, right? You need your temp variable. And you just always remember that the last thing becomes the first thing on the next line. Last thing becomes the first thing on the next line. Okay? Well, let's make it happen now. So, okay. I would like to swap indices I and size minus 1 minus I. So the very first thing I'll do is save it in a temp variable. Well, I guess here, let's, instead of calculating this each time, let's just save the right side, the other index to swap with, because it's I first, right? Swap an index I with this big long thing. Let's just save that number in a variable. Index to swap with. That's v.size minus 1 minus I right now. Okay? And so I'll just swap indices now, I and index I with index to swap with. So I need my temp variable. Save safely away the first thing, v at I. And now I'm allowed to mess with v at I because I've changed, I've saved it in a special place in that temp variable. So v at I can now become the other side, v at index to swap with, right? That's the right side. The index is size minus 1 minus I. And that's perfect. And now this guy, this index, becomes something else, right? It's going to become equal to that temp variable. All right, so the pattern goes like this, right? That matches there, that matches there, and then these kind of like wrap around to each other. And that's how you remember how to correctly swap things. But you can also draw a picture to convince yourself that it's working right. But that should do it. That should have swapped everybody in that vector, and by the time this loop is done, it will have done exactly as many swaps as it needs to. And if I go through the vector with the cool range-based for loop for every int e and v printed out, I should see the contents in reverse order. It's very useful. Let's see. See if it works. Oh yeah, so it was like this. Now it's like this. Beautiful. And that's going to work for any size array. So even if it was like 6, if it was even, it'll still calculate it correctly, do the correct number of swaps. All right? That is lovely. That integer division just gives that to us for free. I like that. Okay, that's reverse in a nutshell. We are now experts. Let's keep on trucking. So we learned a lot of stuff that we talked about last time, like talked about arrays, we talked about vectors, we have all that knowledge in our brains. Let's remember the differences now. So please pause the video and write down the following. So I've given you a bunch of scenarios. Please write down how to do the following for each of arrays and vectors. Like how do you access an element at an index for an array and for a vector, and then do the same for all of these. Okay? For this last one, just write it in words. You don't have to write code because that would take a while. All right, do you see? Did you figure out the differences? Because the syntax is a little bit different, isn't it? So if you want to go somewhere in an array versus a vector, that's a little bit different, right? So if it's an array, you're going to use those angle brackets. Or sorry, not angle brackets, it's square brackets, isn't it? So you go to index I that way for an array, but for a vector, it's the dot at, v at index I. Okay? That's the difference. And then initialization is a little bit different too. It's like the types look a little bit different. The syntax is a little weird for arrays, right? If you want an array of ints, you gotta say int, give it its name, and then array bracket, just like that. So it's like the fact that it's an array is separate from the type of thing that's inside of it. 1, 2, 3. And that'll do it. You can also hard code the number here, how big it is, but it'll figure that out if you give things here. So that would work for arrays. For vectors, the type looks a little different, right? It's vector, and this time it's angle brackets, a vector of int. So all the types all together, which I think I prefer it that way. V equals 1, 2, 3. So that's one way to make it hold 1, 2, 3. Alternatively, you could have said like vector int v semicolon, started it empty because you could do v dot pushback, right? Push back a bunch of values, whatever you wanted it to be. 1, then 2, then 3. You could not have done that with an array. Arrays, they need a size to begin with, and they're never changing that size. Okay? Vectors are cooler like that. And then finally, to make a new array or vector of size 10 with 42 in every index, well, you're kind of stuck, right? There's a few ways to do it. There's probably a loop is the easiest way, but if you're lazy, let's see. Yeah, if you're lazy, I think the loop is the best way, honestly, for arrays. Just like make an array of size 10 for each index, go to each index and set it to 42. I guess if you really didn't want to think too much, you could have just started typing 42, comma 42, comma 42 all day long. That would have worked 10 times. You're kind of stuck with arrays like that. For vectors, you can do the same, right? You can start it off empty and then push back in a loop 42 10 times. That would also work. You can also play this game, 42 and 10 42s within the curly braces. You do have one more option in vectors, and it's really cool. It's called the fill constructor. So you can do it like this. Vector int v, and watch how cool this is. You can say, instead of putting a semicolon here, you can put some parentheses, like you're calling the name of your vector as a function in a weird way. You can say, I would like 10 42s, please. And this will create a vector of size 10 with 42 at each element. That's pretty neat. All right, so that's called the fill constructor. You can look into that in the documentation. Just a bunch of different ways to create constructors. The fancy C++ word for that is construct them. All right, and so here's, which one was it? This is the second one. So it looks a little weird, but there are examples if you scroll down. It's worth reading about. Eventually, you will understand it fully. But yeah, that's a neat little fact. Okay, now you know. So I think that takes us to the end of arrays and vectors. Now I just want to teach to you a special kind of array. All right, it's called a C string. So this implies the existence of C++ strings, and that's the string type we know and love. So when we included the string library, and we said just the word string, that was a C++ string. All right, it's the cool new kind of string. It works very similar to a vector, right? We get a lot of neat stuff out of it. C strings are kind of like the array equivalent. They're the old version. Just like C++ strings are like vectors, C strings are like arrays. All right, and they were in the original C language before C++ strings came out, and they're a little more esoteric and weird looking. But at the end of the day, they are a special kind of array. So let's talk about that. All right. So yeah, we prefer the C++ string data type, but sometimes, and I'll show you a good example today, you are forced to use the old version of the strings. So it's a C string. So that'll work in C++ as well. Let me show you what that means. All right. A C string, all it is, it's a special kind of character array. So it's an array of chars. All right. So the type of a C string is like it's char and then like the brackets after the name. So that's the type of a C string. It's an array of characters. All right. For weird reasons, which I will explain later in the class, there is an equivalent version of this type. It's called char and then a star. So char, star. If you ever see this type, char and then a star after it, that also means array of characters, surprisingly, at least for C string. So it also means C string. All right, so both of these are equivalents right now. Okay, I'll get into in detail what the difference is for both of these, but it's going to take a few weeks. Okay, so both of those types mean array of characters right now, and here's what it means to be a C string. All right, you can't just have any character array be a C string. That will not work. All right, instead you need something special at the end. All right, because like this is an array of characters, sure, but it's not a C string because it's missing something. All right, this is a C string. It's a special array of characters that always ends with this. All right, this little thing. This is the \0 character. It's a special character that marks the end of the C string. All right. So here, let's write that down. Even though I wrote it down before, it's worth talking about twice. So this marks the end of the C string, which is very useful because arrays in general don't know their size. You can just go looking now. If you know it's a C string, you go looking for the null terminator, and then you know when it's finished. Then you know its size, kind of. Marks the end of the C string, and that's what all the library functions on C strings are going to go looking for. Like they're going to go find that, and then they know how big it is, you know how many valid indices there are. You don't have to pass around the size if there's always something to mark the end. That's kind of cool, but that's what it does, all right? That's what this secret character is all about. It's called the null terminator character, all right? That's the real word for it. It just marks the end of your C string, all right? And this is disgusting to type each individual character out. We use double quotes in C++ strings. Actually, the secret is, like everybody hated the syntax, and they actually made the double quotes mean that. All right, so actually, this syntax right here, double quotes hello, is exactly equal to this syntax. All right, it will turn itself into a special C string array of characters. We use this syntax for C++ strings. It just got converted on the fly to a C++ string. But really, whenever you use double quotes, you're really making a C string, actually. It might be converted for you automatically, though. So like this syntax is exactly equal to this because nobody wants to type out each individual character with single quotes in between. All right, this is how you make C strings. Okay, so that I think is all that I want to say. And so like this will secretly add in that extra, well, let's see, what is it? 1, 2, 3, 4, 5, sixth character. That is the null terminator character, the \0. All right, so that's the secret. It's the null terminator character. It's very important. All right, and so like either one of these will turn into a C string that looks exactly like this. It's just an array of characters. It looks like this in memory. So you got your H, your E, your L, your L, your O, and then your \0, your null terminator character. And you can give any of these to all of the functions that print stuff, like cout, for example. You can give it your string as a C string, and it will print it as it knows how, right? It'll just print hello, exactly what you would expect. So it works normally with other things, but that's a C string in a nutshell. All right, I guess I should probably show you that. All right, so far. So here, let's make one the hard way, and then we'll make one the easy way. So char s bracket bracket. It's an array of characters, and let's make the C string hello the hard way. H-E-L-L-O, and then don't forget the null terminator character, \0. All right, that's a C string, and everybody decided that was way too much typing, so they made shorthand for it. So char s2, this is a string s2. I can just say hello, and that's exactly equal to the above. All right, it'll make the same thing in memory, just with a different name. Shorthand for the above. Okay, so yeah, and C++ knows how to print every C string you give it. Give it S or give it S2. It's happy. Oops, what have I done? There it is, hello. Okay, so that's pretty neat. Let's see what else. What else do I want to do right now? Let me just walk you through, I guess, a few different library functions that work on C strings, because you got your C string library just like you had the string library for C++ string. So there's a C string library, and I want to go and look at all those. All right. There's also some pieces that work on C strings. There's some functions on C strings in the cstdlib, the C standard library header file or library name. Okay. So let's talk about a few of these. Let's go and pull up both of those pages. Maybe let's get them ready. So it's in the C library, both of them. So you got cstdlib and C string. They should be next to each other because they're in alphabetical order. Very nice. So here's cstdlib. You got a bunch of things, including rand. Don't forget rand and exit and all those. Those are not C string functions, but some of these are. You got some string conversion functions in cstdlib, and you got a bunch of random C string stuff in the C string library. All right. So yeah, let's talk about one of the conversion functions. This one lives in the cstdlib file. So it's called a to I. All right. So what this function does is it converts a C string to an integer. All right. Converts a C string to an integer, and that's what the I means. Like A means like alphabetic, I guess, characters. So string to int. That's what that is. So that's what it does. And look, if we click on that, A2I, it takes a C string as a char star. Remember that that type is equivalent to C string, right? An array of characters. And it gives you back the int form of it, all right? That's exactly how it works, A2I. So C string to an int, because you know that there's a huge difference between the string 4, right? That's just the character for 4, it has no numerical meaning, and the number 4, all right? The one that you could do math on. So let me show that to you. That's A2I, and it lives in cstdlib. So I better include that one first. I think that is, yeah, I don't need to draw anything. Let's just keep on trucking. So let me make a new C string, char S3 bracket equals quotes 42. So this is the string 42. It has nothing to do with the number 42, right? It's just the characters in memory. You can't like add it to anything and expect to get a result. It is not the number 42. It's the string 42. It's the textual representation of it, right? It's not actually in it. So we can convert it though. Okay, we can convert it. So watch what happens if you like mess up. Like I want to multiply 42 by 2. Pretended it worked. Let's see if it even compiles. It does not even compile actually. It's like, no, sorry, you cannot multiply a string by an int. That makes no sense to me. All right, so it won't even accept it. But what you can do is, I know that this represents a number, so I can convert it. So that's what A2I does. You give your string to A2I. It will give back the integer form of that string, so it will convert it to the real number 42, and then you can use it in your larger context. All right, so there's my 84. Perfect. It's going to do it right. I think that's all that I wanted to say. So yeah, just remember the huge difference between strings, which are just characters, and numbers. Some strings represent numbers. You'll have to convert the types though. Okay, so there's that. There's also in the string library, the C++ string library, there's one called S2I. You can do, that works for C++ strings, and then because every C string can be up converted to a C++ string, you could have been using this one too all day long, but it's fine. I'm teaching you this one right now. Right? A2I converts a C string to an int, but S2I will convert any arbitrary string, including C++ strings, to integers. So yeah, you have options. So that's the first one. And now the rest of these live in the C string library. Okay, so let's go and look at the C string library and talk about those. So I guess the first one is called strcat. It looks a little weird. This one's like the plus operation essentially on C strings. So what you do is you give it two things, strcat. You call it with two things. I guess it's the destination C string and the source C string is what they call it, and it will return back to you the destination, I guess. You don't usually use the value that it gives you back. You just like you use the effect that it creates. But it does give something back if you want to look into that. But you give it two arguments, all right? It takes two arguments, but it somehow adds two strings together. So what is it really doing? So strcat works like this. You give it two C strings, let's call it S1 and S2, and it adds them together and puts the addition in the first string. So this is essentially equivalent to, if you could do this for C strings, the following. S1 equals S1 plus S2. If it worked like a C++ string, that's essentially what happens. So it like tacks on S2 to the end of S1. That's why it was called destination in the documentation. So you do have to make sure that there's some room, there's some extra room in your first string, right? Because it's going to have some things towards the end of it. Does that make sense? So that's important. So let's see. Here's kind of how you make sure of that. Let me show you some code and then I'll draw what's going on. So let's say that I want to make the string like hi mom or something. So I'll do like char S4 bracket is the string hi space, and then S5 is mom exclamation point. I cannot do strcat right now on these. S4, S5. Because what this is going to do, right, is it's going to set S4 to be itself plus the end of S5. Like add S5 to the end of it all. And I need, sorry, the C string library to make that work. Whee. So this is not going to work right now because there's no room at the end of S4. It can't add more things, right? That would give me undefined behavior. I don't like that. So this only has how many things? What does S4 look like right now? Because I need some extra space. So S4 currently looks like this. It's got high space in it, and then remember that there's secretly a null terminator character. So really, S4 is an array of 4 things, h, I, space, and null terminator right now. Okay, those are where the indices are. 0, 1, 2, and 3. If I want to tack more stuff onto the end of this string, I need more space in S4. All right, and here's how you do it. Here's how you can do that. You can just be like, S4, pay no attention, like fill it in at the start with this stuff, but actually make a char array of size 50. All right, what this does is it makes sure that there are 49 or 50 indices up to 49, and it's going to fill in the first ones with the string that I gave. So there is up to index 49 now with this syntax, but it fills in the first pieces with high. And that's fine, because when you're printing stuff, it just goes until the end of the string, not the end of the array. That's how it kind of knows when it's done. So that's what the null terminator is good for, and that's maybe not a good enough backslash. Let me redraw that. It's not leaning far enough. Backslash 0. All right. So what I've done is I've made some empty space that will be now taken up when I do strcat. So now there's room to put mom exclamation point at the end of this. All right. So let's run it now. And then we can print out S4, because now it should hold stuff. So let's see here. Yeah, let's print out S4. And watch that it's going to be correct. It's got the high mom, and when you think about it, this is what's going on under the hood. Like, it used to be this. S4 used to be this, and it turned into the following. Right now, it's equal to, it's got your H, your I, your space, and then what used to be the null terminator character, like, we're not done yet, right? We added more to the string, so it's not over yet. So we started adding the M from the other string. We add the whole other string to this. M-O-M, exclamation point, and then the string's over, so that's where it puts in the new null terminator. Essentially just brings in everything, including the null terminator from the S5 string. So that is what S4 looks like right now, and there's still extra space towards the end of that. A bunch more indices, right, because I made a bunch of extra room. And that's what's going on under the hood, but when you print it, of course, it's just going up until the null terminator, and that is essentially what the string looks like to C++. That's pretty nice. That's useful. Because there is a null terminator, you could probably write this function one day. There is a strlen function that gives you back the size of your C string. I hope that makes sense. That's a useful one, right? And it's very easy to figure out the size of a C string because you can just go and look for the null terminator. Where is it? Strlen. There it is. Just gives you the length of a C string. So it gives you back, takes a string, gives you back it's an unsigned integer, if you remember reading about that in your book. It's just a big long number that can't be negative. All right? Think of it as an int. It's going to give you back the size of your string. It's going to only count the real characters, though, so you do have to be careful. If you're thinking about using strlen for size purposes, really the size is one more in the inner array. So see how it's, let's do strlen of, let's do S2 maybe? It's my hello string up there. So the size of S2, as far as strlen is concerned, is 5 right now, even though really there's that null terminator, the 6th special secret character is in there. It's strlen just is going to give you the size of the string part, not including the null terminator. Doesn't count the null terminator. All right, so just be aware of that. If you ever need to, like, I need exactly this many things to hold a new string, I need exactly this many indices, add 1 to strlen, right? I think that's all that I wanted to say for that one. So that's a useful helper function that you're going to need one day. And then the final one that I want to show you is the weirdest one. It's called strcomp for string compare. They really liked their 6-letter function names in the C library, you can tell. Strcomp is short for string compare, and so it takes 2 C strings, and it gives you back, disgustingly, a number. Where is that one? There it is. Takes 2 C strings, and it gives you back an int, which is disgusting. And what it does is it gives you back a number that tells you kind of how they're ordered. So again, this is going to do that lexicographic ordering, check for the dictionary order, and tell you, like, does S1 come before S2? Are they equal? Or did S2 come after S1 in the dictionary? Stuff like that. So I think I just said the same thing twice, didn't I? Like, did S1 come before or after S2, or are they the same, is what it's going to check for, all right? And so it's going to give you back a number to represent that idea, okay? And so what's going to happen is it will give you back a negative number, just some negative number, if the first string comes before the second one in the dictionary. Okay, it's going to give you back a negative number, some negative number. You have no control. If the strings are equal, it will give you back the number 0. And then if S1 is bigger than S2, it comes after it in the dictionary, it will give you back some arbitrary positive value. All right. And kind of the reason why it gives you back these numbers is it's just subtracting ASCII code values. So like, say you're comparing AAA and AAB. What's going to happen is it's going to go through each character in order and compare them. Like, okay, those are the same, so the difference is 0. Subtracts these two from each other. Like, difference is still 0, but I've got more to check. And then it gets to these guys, and it's just going to do that one minus this one, and so that's going to give you back some negative number. Okay, I hope that makes sense, because this one was before it. So that one had a bigger ASCII code. The B had a bigger ASCII code than the A. And so that is, that's kind of why it gives you back numbers, if you think about it. But you don't have to remember that. Just like negative means smaller, the first one's smaller. Positive means the first one's bigger. 0 means they were equal. Okay, so that's string comparisons. Yeah, I think we're ready for an example of that. It's very weird, I know. So here, let's just do a bunch of examples. Str comp ABC BCD. To see all the options here. Let's do one for BCD ABC, right? Let's do one where they're the same. And yeah, I think that's good enough, right? So here's what we get. You have no real control over the values that it gives you back, but it's going to give, at least for this implementation, it looks like the library is always going to give like -1 or +1. So here it is. ABC comes before it, so I get a negative number. BCD is very big, right? It's bigger than ABC, so it comes after it in the dictionary, so that's a positive number. And then 2 equal ones, it's 0. And so you can compare arbitrary strings, like it doesn't have to be like just whole words. It's going to do weird ASCII code comparisons though. Like you can totally compare hello to hi mom as far as C++ is concerned. As far as strcomp is concerned, like this one is smaller. It would come before it in the dictionary because it's HE versus HI. Okay, so at the end of the day, it's just comparing ASCII codes. So be careful with like capital letters and stuff like that. Those might compare differently than you might expect them to be compared. But yeah, the moral of the story is usually you're going to want to check if 2 strings are the same. Like we care about doing that a whole lot, right? We don't care too much about like, does it come before or after in the dictionary? We care a whole lot about equal strings a lot of the time. I made a bunch of programs with checking for string equality, right? So for C strings, you got to do it this way. It's got to be something like this. Like if call string compare of S1 and S2 is equal to 0, essentially. That's what you're going to check for. Like they're equal if string compare gives back 0. All right, so that's what you'll check for. Was the result 0 after calling string compare? And then you do what you want to do if the strings were equal. That's how you check for C string equality. All right, you can't do something like this. This does not work. S1 equal S2. That does not work. Okay, that does not work for C strings. It only works for the normal C++ strings. You got to use strcomp for C strings. I think that's all that I want to say. That's my final warning for the slide. It is all very weird, I know, but we are forced to use C strings for at least one thing in this class, and here is that one thing. All right, it's called command line arguments. So we run our programs like this, right? We compile to a name, we say / that name, we hit enter, our program runs, but we have a bunch of other terminal commands that are just those are just compiled programs too, that take more things, like G++, right? That's a terminal command that somebody compiled that, right? And like we're able to give it extra things. Like we can give it the name of a file, -o, call it A, blah, blah, blah. Even the CD command, right? It takes extra stuff after the name of the thing. We want to be able to do that, right? So that's called command line arguments, okay? So we can now have the ability to do this, right? I'm going to show you how. Like you can do your /prog and also get things and give things and access them. It's like space 42 space high or something. All right, it's like we're going to be able to do that and hook into getting these out. All right, I'll show you how. So the reason it's called command line arguments is because kind of like you pretend the name of the program is a function almost. Pretend prog is a function. And so you kind of see how in this syntax then we're calling it with arguments, 42 and high on the command line. That's why it's called that. Okay, so that's why it works, and so you need to be able to access them, all right? There's a way secretly to get access to these things after the name of the program as your program's running, all right? And the answer is through the main function, all right? I guess I've not told you something, and I'm ready to tell you something new, all right, about the main function. So I've hidden something from you. So there's actually two ways to make a main function. You can say int main, as we have been, right? Parenthesis, parenthesis, some dots. That's the normal main function that we've been using, but that's not the one that's able to access the command line arguments, all right? So there's another one. There's a separate one. There's a different one that's better, I guess, in this case. If you do your main like this, and I'll explain what I write in just a second. If you do your main exactly as I'm about to write, that will give you command line arguments. So instead of empty stuff between the parentheses, you do the following. You say int, and this name doesn't have to be anything special, but people tend to call it argc, and then but the type has to be an int for the first thing, and then char star argv bracket bracket. So the name again, people call it argv. You could have made this x or y, doesn't matter, the name, but the types are very important. It's got to be an array of char stars. Disgusting. But this, if you do it this way, it will give you access to the command line arguments, all right, through these things, through these variables, okay? And so let me mark this up and try to tell you what this means, all right? So first of all, when you use command line arguments, it's gonna, just like the terminal, is gonna give your program argc and argv based on what you typed here, all right? So argc, I guess I'll use, let's see. These are very important. So I'll use rainbow for them. And so argc is short for argument count. Arg count, that's what people call it. And so it's an int, and it just gives you the number of arguments on the command line. The number of command line arguments that your program was given, all right? And then argv is short for argument vector, all right? I know that's a horrible name because we know what vectors really are, and it's secretly an array, but give these people some slack. This was before the C++ language existed. They came up with this word. So just interpret vector in this situation as array. It's just another, it's a synonym for array, sadly. It's very confusing, I know. But let's see. Argv, what it is, it's an array of char stars. It's an array of C strings. Let me write that here. Argv is an, I'll use color coding for this. This part means array, right? It's an array, and then what's in the array, what's at each element? It's an array of this type, all right? It's an array of C strings. And so I need one more word, don't I? Argv is an array of C strings. That's how you read it. And so these two working together give you, like, this is the text of your command line arguments, and this is how many you got, all right? So that you don't go towards too far out the end of it, because remember that arrays don't know their size, so here is its size. So with that in mind, let me break it down further, because I know that's still just a bunch of words, and it doesn't make a lot of sense yet. So yeah, as far as the terminal is concerned, as far as your program is concerned, all of your arguments are just separated by a white space. You can put as many spaces as you want. You can tab over if you need to. But all of your arguments are space separated, and that's how it differentiates, all right? So for example, if you did this, if you made your main function like this, and you compiled, and you ran this exact program, /prog, space 1, space 2, like space separated prog, 1, 2, high and mom, then argc and argv will be set to the following, all right? Argc is going to be set to 5. It is a count of all of the space-separated words. So the name of your program counts as an argument, technically, I guess. 1, 2, 3, 4, 5 space-separated things. So argc is going to be set to 5, and that's going to be the size of argv. So argv is going to give you, it's the array of all of your arguments, all right? So it's an array of C strings. So argv will be, when you run it like this, it will be set to exactly this, /prog, 1 the C string, 2 the C string, hi the C string, mom the C string. So it's just a bunch, it's 5 C strings, argc many, holding the text of each command line argument with all the spaces taken off, because that was just used for separation. Okay? That's the secret. All right, so let's make a program that kind of works like this, that just prints out all of our command line arguments as well as the number of them, and it'll run like this. All right, so let's make that program first to just like remember everything and get some practice. I'll make a new file, command line args.cpp. So all right, instead of declaring main like this, we're going to do it in the fancier way. We're going to say int argc char star argv bracket bracket. I know that's a lot, it's a mouthful, but you'll get used to it. So remember that argc is short for argument count. It is the number of command line arguments, including the name of the program, that counts. All right, and then argv is short for argument vector, even though it's an array, argument vector, and it contains the contents of your command line arguments, the actual text of them. As C strings. All right, so it's an array of char stars, so it's an array of C strings. Okay, that's how that works. And yeah, let's just spell that out too. So it's an array of C strings. That's how you think of it. And so let's use it. Like, all right, when I run this program, I have argc and argv to access now. Let's say, all right, print out argc, and then we can go through argv as well. But let's just print out argc right now. Boop. So when I run it like this, there was one, right? It's just the name of the program. There was just one. But if I start adding things like hi mom, now there's 3 things. See that? And space separation doesn't count. I could add a bunch of spaces, could add a tab even if I wanted to. It just like only counts non-space things. So it's still 3 arguments. So that's what argc is given me. And so that's really the size of the argv array. So that's how many things are in argv. It has an index for each of those pieces of text that I typed here. So now let's iterate through argv and access everything. So it's up to argc -1, right? Size -1. For int I equals 0, go all the way up to argc -1. That's its size, right? So strictly less than argc I++, and each argv of I, right? That's a C string, and I can print that. I can print out each of those, okay? And so let's print it in a pretty way. I'll be like argv of I is set to :space whatever was actually in argv of I, and then a new line. Okay, that's it. Watch. Yeah, I think that's how I want to do it. Let's recompile, and then I'll rerun. Let's just do it this way, the first way. This is only one command line argument, right? And so argv of 0, that's the text of that. But if I add more, like hi, as many spaces as I want, doesn't matter. Hi mom, it's going to get rid of all the spaces, and there's 3 things, right? 3 things. The first one is the name of the program always, argv 0, and then it was hi, and then mom. It got rid of all the spaces. Those were just used for separation. And remember, even if you type numbers, like 42, 3, those are gotten still. Those are 5 command line arguments, right? Including the other ones. And now we got 42 and 3, but as C strings. These are stored, argv. Every index in RV is a C string. It's not a number yet. If you want to do number stuff, you have to convert it with like the A2I function. All right. So that's the secret though. That's a way to access your command line arguments, and I don't have to rerun the program to give it new things, right? Give it 34 now. Look at that. I just rerun it with new command line arguments. Rerun the existing program with new command line arguments. That changes the input. That's kind of neat. Yeah, I think that's what I want to say. So this is another way to give input to your program. Instead of cin, you can now also use command line arguments. That's one thing I want to say. And now let's do an example of using command line arguments to do something cool. Let's make a program that draws a square Oh no, I'm losing my voice. Let me get some water real quick. Excuse me. Almost home free. Let's see if my voice lasts a little bit longer. So let's use command line arguments to draw a square. All right, so I want to make a program called draw square, where the user tells us before we even run the program how big of a square like they want us to draw. So like maybe 5, maybe 55, doesn't matter. But that's where I want to put it. I want in the command line arguments, I want the user to tell me how big of a square to put right there. Okay? So that's the secret. And so we want our program to only run and write and access this thing, right, if the user gives us a number. So we have to check. Let's ensure that the user gave us the right number of arguments. Because like, what should argc be? If I want to be able to run a draw square program exactly like this, I always want a number here. What should argc be set to? Can you see it? Remember, the name of the program counts. What is this blank? Argc should be, whenever I run my draw square program, if I always want the name of the program, that you're forced to have that, and then the size of the square, argc should always be 2. Does that make sense? Because like argv of 0 is the name of the program, and then argv of 1, I want that to exist, right? I want there to be 2 separate things, and this will be the size of the square I should draw. And so it's going to be argv of 1, right, that I go and look inside. Assuming argc is set to 2, argv of 1 should hold the width of my square as a C string. And also the height, because it's a square. It holds the width as a C string. Okay, so I think that is enough to get started. So let's make a program that has the fancy kind of main function that can access command line arguments. Let's enforce the fact that we want exactly 2, and then go off and use the second one to draw a square. So here, let's do a new file called, I guess we'll have to draw it, we'll have to call it draw square, right? Draw square. And so, fancy kind of main, int argc, char star argv, bracket bracket, okay? And so the very first thing I want to do is make sure that I got exactly 2 command line arguments, all right? So let's make sure that happens, or let me just show you what happens if we don't. Let's pretend that the user is nice, and like argv of 1 is going to be where the width is. So let's just access that. Let's just pretend it exists. Pretend the user did it right. So the width is argv of 1, right? But this is just the string right now. This is like 42 the string, 5 the string. I want 5 the int, don't I? So I'm going to use a to I. I'm going to use the conversion function to fix that. So I can say a to I here. Boop. Oh, darn, that's in the wrong spot. There we go. I can say a to I, and that will convert that string into an actual number, and then I can use it, right? I can now draw a square of that width. So for int I equals 0, I is less than width, I plus plus. Let me just quickly draw a square. You remember how to do that, right? So that's with many lines, and now with many columns, right? Int j equals 0, j is also less than width, j plus plus. I'm going to draw that many stars, right? And then that's a line of width stars. I want to break the line, and then do that exactly width times. That will be a width by width box of stars. You see it? So here, let's recompile, or I guess compile for the first time. Boop. And this is what happens when you try to access a command line argument that does not actually exist. So this is why we need to enforce the fact that we should have 2 things, right? Because if I give nothing, it'll try to access argv of 1, but that's not my memory right now. That index doesn't exist. You see that? That's the problem. If I did it right, though, I did draw square 5, it would find it and do the right square. And that's pretty cool, right? Draw square 5, draw square 4, draw square 3. It's always going to work. That's super neat. But yeah, so that this does not happen again, right? This error. Let's just enforce the fact that argc should always be 2. Then I know I have something here. Okay? So if argc is not 2, I want to stop this program. I'm not happy about this. All right? So cout, like, must run with a single number, exclamation point, new line. We're going to yell at the user right now. And then we want to stop the program. So let's stop the program with, I've already included cstdlib, so we can use the exit function. I could either return or say exit. And when there's an issue, when something was like, when an error occurred, returning 0, remember that means success. So I'm going to return 1. I'm going to say exit with a return code of 1, not 0, because the program did not end successfully. If we drew a square, it ended successfully. This one is wrong. So I'm going to say return with an exit code of 1. So I could either do that, or I could just say, because I'm in main, I can just say return 1 as well. That's equivalent. But I like the exit function because it'll work anywhere. That'll stop the program. Okay? So that's pretty cool. And so let's make sure that works. So now if I say draw square 3, it'll still work like that, but if I give too few, must run with a single number, or too many, like 42, 42, that's still wrong, right? That's still checking for that. That's perfect. Another cool thing that I can do, because in argv of 0, I always have the way that the user ran the program, I could tell the user how they should have run the program right now. Like, I don't know, like they could have called it anything. They could have called it draw square. They could have called it just /draw, whatever it was. However the user just ran the program right now, I have that in argv of 0. Does that make sense? So I can tell them how they should have run it. It's like, all right, here's the usage of this program. Here's how you should have run it, user. You do your / or however you ran the program. That's sitting in argv of 0 right now. That's where /draw square is, or whatever it was called. Doesn't matter. And then it was supposed to be that, and then a space, and then a number, right? N, where N is a number. That's very cool that we can do that. All right, I hope you see that. See the power there. Watch. Draw square, 42, 42. It's like, no, this is how you should have run it, and it's getting the name of the program from here. If the name of the program was something different, like maybe I just called it draw, /draw now, 42, 42, it's still going to get that name, because it's sitting in argv of 0. Isn't that amazing? I love it. So yeah, let me remove that draw file. We'll go back to just the draw square one. Beautiful. All right, and it's going to work for if you do it normally as well. It's still happy. All right, it gets past all that. I think that's a cool little example. That's the power of command line arguments. It's a new way to give input to your program before it even runs. I hope that makes sense. So yeah, you do have to be very careful and make sure that, like, if you're trying to access argv of 1, you better make sure it exists. argv of 0, you know, is always going to work, right? Because that's always the name of the program. You can't run the thing without giving the name of the program. So there's always at least argv of 0. So argv is always at least 1, but any more than that, you better check for. Okay. So yeah, that's a fun program to go and study. Do yell at me if you have any questions about it. The last thing I want to do today is, I think there's a little bit of time, let's talk about this program. It's just a fun, weird example. Let's write a program that does the following, all right? Let's have it take command line arguments, so we'll get more practice with that, and we will output those same command line arguments, we'll spit them back out after doing the following, all right? I would like to do the following to each command line argument. I would like to capitalize every letter in each command line argument. So CC type will give that to me, right, with the to_upper function. And then every digit character, that is, in each command line argument, I would like to shift it over. So like make every 0, 1, every 2, 3, every 3, 4, every 9, like 9 can go back to 0 or something. That's what I want to do. So like, if I run this program, and I give it blah, and then high 42 as my command line arguments, I would like the program to produce the following. I would like it to spit out all caps blah, and then all caps high, and then instead of 42, I want it to be 53. Does that make sense? That's how I want to change things. It'll give us some practice with string stuff, C string stuff, as well as command line arguments. So I think that's worth it, worth a try. So I do encourage you to try this first. Pause the video, see how far you can get, and then I'll show you my way of doing it. We'll just skip over the name of the program, so we'll start straight from argv of 1 onwards. Okay. So here we go. I'll call it capitalize and shift.cpp. So main function that gets command line arguments, and now I've got them. And what I want to do, right, is I want to iterate through all of the command line arguments that aren't from the name of the program. So starting at 1, right, starting at index 1, and then go and change everything. Iterate through all the args after the name of the program. And so that will be not starting at index 0, but index 1 of argv. Right? So for int I equals 1, and just like go until the end. I is less than arg c I++. And this will work even if there's only one command in that argument. It just won't run the loop at all. So it'll skip over it, right? So just go for every valid index into argv starting at 1 though, right? So that's that one. Yeah, so like we're going through, we have I being each index, right? Each index that I want to mess with. So like, all right, for each body of this loop now, it's just like mess with the string argv of I. Does that make sense? Like that's the string I want to mess with right now. It's like maybe it's the blah, maybe it's the high 42. Let's go and change things, all right? And so just for fun, I could go messing with characters because like argv of I of 0, right? That's the 0th character of the string. 1 is the 1th character of the string. That gets a little ugly looking and hard to understand for CSCI 40 students, I assume. So let's just save the string that I want to mess with in an intermediate state. All right, so here, I'll say char star, right? Remember that's the same as an array of C strings. Like that's, I guess that's a type of everything in argv, so I can use that as the type of just a helper variable. So char star s equals argv of I. All right, so now I've called the string that I want to mess with. I've called it s instead of argv of I. Okay, so s is the current command line argument I want to work on. Okay, you see it? So that's the secret there. And now I want to go through that string s and change pieces of it. All right, I'd like to process every character of s. And so this is going to turn into a nested loop just naturally. All right, so now I'm within like one of these iterations. Like I'm either working on the blah string or the high 42 string, for example. And now I want to iterate through each character of whatever string that was. And so that's going to require an index, right? I want to go to every valid index of this string s. So for int j equals 0, j is less than the size of the string, right? The size of the string, and it's a C string, so I can get that with the C string library and the strlen function. All right, that's using all the stuff we learned today. Strlen of s, j++. So now j is the index of s that I want to work on right now. So s of j, because every C string is just an array of characters. S of j is the current character I want to mess with. So I hope you see how we're like zooming in. So this is like iterating through all the strings that I want to mess with. So here I've got each string that I want to mess with. And now for each string I want to mess with all of the individual characters that make it up. So s of j is my current character. What do I want to do to it? Now is the question. I want to make sure that it's capitalized. So each character needs to be capitalized if it's lowercase. And I also want to shift over any digits. So CC type is going to help me with the capitalization. Remember that it's the toUpper function in CC type. We can go look at that real quick. Where is that? There it is. So toUpper, remember, is going to take a string, or sorry, take a character, give you back the uppercase version of that character. It leaves it alone if it was already, it'll give you back the same character if it was already uppercase or it wasn't alphabetic. But yeah, that's where we're going to start with. Like s of j, replace it with yourself, but uppercase if it needs to be. toUpper. toUpper of yourself, please. And if it was like a digit or something, it'll just keep it the same. So toUpper only affects it if it was lowercase. So there's that. And so it will change it to the uppercase equivalent if it needs to. And then now I want to mess with the digits, right? If it was a digit, after all, like it was the 4 or the 2 or whatever, I want to advance it. I want to make it the next bigger character, right? The next bigger digit character. So let's see how this is going to work. So if s of j was a digit, then I want to shift it, right? Shift it over by one digit, and then wrap the 9 back to 0. So how do I know if s of j, if that character was a digit? CC type to the rescue again. You got your isDigit function. You call it, and it gives you back true if it was a digit, false if it wasn't. So I can just say if isDigit s of j gave back true, right? That means it was a digit. And then also remember, this is redundant. I don't have to say equal equals true. It's just like it runs the body if this result is true. So just like if sj was a digit, that's how you can read it. It'll run the body if it gives back true. I would like to advance, right? S of j equals something, right? 1 more than it was usually, right? 0 becomes 1, 2 becomes 3. So there's going to be a trick here, and it's going to involve the ASCII table again. Boop. So if we go to the ASCII table, and we look up all of our digit characters, here's where they live, right? Apparently the 0-digit character is ASCII code 48, 1 is ASCII code 49, 2 is ASCII code 50. Ooh, do you see the pattern? They go in order. So like whatever the current ASCII code is, like if it's 0 or if it's 4, right? I want to make it 5. I just need to change the 52 to the 53. Or if it was 2, I want to make it a 3. I just need to change the 50 to the 51. So whatever the ASCII code is, just make it 1 more. You see that? That will work for everybody but 9. 9 is unfortunately going to be turned into a colon right now, but that's most of the way there. S of j, just advance it. S of j plus 1. Could have done S of j plus plus if you wanted to, I guess. But that's going to do it, right? It's going to shift the digit over. And that is most of the job, right? So here I am. I've got the string I want to mess with. I have I have processed every character at this point. Like I've gone through them all, done most of what I need to do. I just need to change this a little bit later. And then like after I'm done, I've changed S, right? S is a C string. I can print it out. Print out my new changed messed with C string, S. Does that make sense? So that should do most of it. Let's compile and run now, because there is going to be a little bit of an issue with those numbers, right? Boop. Well, I need to give it some chameleon arguments, don't I? I need to say, let's do blah and high 42. Yay! So it does work. It does all caps blah and high 53, but if I say high 49, then it's 5 colon because of the way that ASCII codes work. So adding 1 to the 9 character made the colon character, funny enough. So we just need to fix that with another if statement. So like usually you're going to do this, but if it was a 9, you got to wrap it back manually to 0. So that's just an if within the if. Okay, so if S of j happened to be that 9 character, then I do not want to advance it. I want to set it to 0, just manually. Otherwise, if it was any other digit character, then this rule works, right? Just advance it to the next one. It'll be happy. And that'll fix it all. So it'll still do the old one. High 42 becomes high 53, all caps. And then if I change this to a 9, then it becomes high 50. The 9 turns into a 0 thanks to this if-else. All right, so this is a fun little piece of code to study. It's got a lot of stuff that we want to practice in it, right? We've got a bunch of C-string stuff and command line argument stuff. So yeah, definitely study this. Try it yourself. See if you can do it without looking at the notes. That would be great practice. And yeah, just yell at me if you have any questions about this program. That's probably the most complicated one of the day, right? But I do get to congratulate you now because we've made it to the end of this set of slides. Yay. So we are experts on arrays and vectors now, and then also C-strings and command line arguments. So yeah, I think that's all that I wanted to record today. I will see you all in the next one.